Imagine you're driving a self-driving car, and suddenly the vehicle must process a flood of real-time video data from sensors. If it sends all that information to a distant cloud server, there's a delay, like waiting for a response in a slow-moving line. That's the problem traditional systems face. But what if the car could process this data locally, right at the edge of the network? That's where edge intelligence comes in. Edge intelligence brings computing power closer to where data is generated, like your phone, a smart home device, or even a self-driving car. This reduces latency, saves bandwidth, and keeps your data safer. But here's the catch. Edge devices have limited resources. They can't handle every task as efficiently as a cloud server. So how do we make AI agents, like the ones powering your smart assistant or autonomous systems, work seamlessly in this tricky environment? This research tackles that exact challenge. The team developed a smart system for placing and moving AI agents at the edge. Think of it like a traffic control system for AI. When a user moves or a task changes, the system decides where to deploy an AI agent and when to move it, optimizing for speed, cost, and performance. So how does it work? The researchers modeled the problem like a puzzle. They considered factors like processing power, storage, and network speed. Each edge server is like a player in a game with limited resources. Then they used a clever algorithm inspired by ants. Ants find the shortest path to food by leaving pheromone trails. Similarly, their algorithm traces the best routes for AI agents, balancing latency and resource use. Here's the kicker. Instead of moving entire AI agents, which is slow and costly, the system only transfers essential data, like a snapshot of the agent's current state. This lightweight migration keeps things fast. They tested this on a global network of edge servers, and the results. Deployment latency dropped by 9.5%, and migration costs fell by 11.5%. Why does this matter? It means smoother experiences for users. Your smart home devices respond faster, self-driving cars make split-second decisions, and sensitive data stays closer to you. Plus, the system adapts in real time, like a flexible team that reorganizes itself to handle new challenges. This isn't just about fixing a technical problem. It's about making AI more reliable and accessible. As edge networks grow, solutions like this will power the next generation of smart technologies. So the next time you interact with an AI assistant or a connected device, remember, behind the scenes, systems like this are working hard to keep things fast, secure, and seamless. Thanks for watching. If you want to dive deeper into how AI is reshaping our world, hit subscribe. Stay curious. Ever wondered how AI systems keep running smoothly when you move around, or when servers get busy? Today, we're diving into a smart solution for managing AI agents on edge servers. Think of them as tiny digital workers that process data close to you, not in distant clouds. Let's break down how researchers are making this happen with a clever algorithm called AntLLM. First, let's understand the problem. Imagine you're using an AI app that needs to switch servers as you walk from your living room to the kitchen. Or picture a server suddenly getting overloaded with tasks. How do you decide where to move those AI agents to keep everything fast and efficient? This is where two key challenges come in: Edge Agent Deployment, EAD, and Edge Agent Migration, EAM. EAD is all about initial placement. You've got limited resources, like CPU power, memory, and storage, and you need to assign AI agents to servers without overloading them. It's like packing a suitcase. You want to fit everything without breaking the zipper. The goal? Minimize costs and delays while respecting those resource limits. Then there's EAM, the migration part. If a server gets too crowded or a user moves, you need to shift AI agents to new servers. But moving isn't free. It takes time, uses resources, and might disrupt dependencies between tasks. The researchers model this as a net gain calculation, balancing the speed improvements from moving against the costs of migration and potential hiccups in task coordination. So how do they solve this? Enter AntLLM, a two-part system inspired by ants. Let's start with AntLLM placement. Think of ants exploring a path. They leave trails, pheromones, to guide others. ALP uses a similar idea. Each ant in the algorithm tries different server assignments, guided by two factors. 1. Resource availability, which servers have capacity. 2. Latency expectations, which servers can process tasks fastest. These ants deposit pheromones on promising paths, gradually converging on the optimal solution. It's a dynamic, adaptive process that avoids getting stuck in local minima. Then there's AntLLM migration, the migration component. When a server becomes overloaded or a user moves, AMM evaluates whether moving an agent is worth the cost. It calculates the net gain by comparing latency reduction from moving to a better server, migration cost, time and resources, dependency risks, e.g., if the agent's tasks are interdependent. If the net gain is positive, the system initiates a lightweight migration, transferring only the agent state snapshot, not the entire model. This keeps the process fast and efficient. Here's the science. AntLLM combines two powerful ideas. First, ant colony optimization, a technique inspired by how ants find the shortest path to food. Then it adds LLM, large language model assistance, using AI to predict and adapt to changing demands. The result? A system that thinks ahead, minimizing delays and saving energy. Let's look at the numbers. When the number of tasks increases, say from 10 to 50, latency, the time it takes to process tasks and resource use, like CPU, memory, or storage, naturally go up. But AntLLM, it slashes total delay by 10.3% on average, and cuts resource consumption by 38.5% compared to older methods. In some cases, the improvement jumps to 49.6%. This isn't just about speed, it's about resilience. Traditional systems struggle with dynamic workloads, but AntLLM adapts like a living organism. It's a glimpse into the future of edge computing, where AI doesn't just respond to demands, but anticipates them. So what's next? As edge networks grow, solutions like AntLLM will power everything from smart cities to autonomous systems. The next time you interact with an AI assistant or a connected device, remember, behind the scenes, systems like this are working hard to keep things fast, secure, and seamless. Thanks for watching. If you want to dive deeper into how AI is reshaping our world, hit subscribe. Stay curious.